In this video, I'm going to give you some examples for simplifying exponents when you have fractions. Now in my previous video, I gave two properties that we're going to go through in this set of examples. And the two properties that I went over were quotient of powers property and power of a quotient property. And so I want to show you how to use those two properties of exponents in these four examples. So for example A here, when you're multiplying a fraction times a fraction, you really just multiply straight across, the top times the top and the bottom times the bottom. Now I'm just going to start by rearranging the top terms, and I'm going to put the numbers in the front together. And then my letters I'm going to put in order. So x squared, then this x here, so alphabetic order, and then a y and a y squared. And then in the denominator, a 3, an x, and then a y squared. Now I notice I can do some canceling because some of my terms are the same. And so what I'm going to do is cancel those terms out. So on the numerator, I see I have an x and an x that can cancel there. I see a y squared and a y squared that are identical that I can also cancel. And I notice that my 9 and my 3, I can do some canceling here. 3 goes into 9 3 times. So now if I simplify what's left, 2 times the 3, I get the number 6. Now I have my x squared and my y left over. And in the denominator, I'm left with nothing. So I could put over 1, but I don't need to because my denominator canceled out. Now in example B, you could do this one of two ways. You could distribute your 4 to every letter and every number, or you could actually write your term out 4 times. So either way you'll get the same thing, but 2x over y squared times a 2x over y squared times 2x over y squared times 2x over y squared, or maybe more quickly, 2 to the 4th. X will have 4 of those, distribute that power. Now y squared will have 4 of those. We want to multiply a power to a power. 2 to the 4th is 16. And in the denominator, 2 times 4 is 8. For my next one, if I do the same kind of process as what I did for the first example, and I just rearrange my terms, I'm going to have negative 6 times 16 for my numerator. Then in alphabetic order here, m before my n, m to the 3rd. I have another couple m's here, and then my n to the 4th. So that's all my top terms multiplied together. And then 4 times 6. And then in alphabetic order, I have an m, and then an n here, and an n here. So now if I do some canceling, I notice that my 6 and my 6 can cancel, because those are the same. 4 can cancel with 16, because there's 4 4s and 16. Now if I have m squared and 1m, let me cancel my square and cancel this m. Now if I have 4 n's and I take away 2 of them, I'd be left with 2. So let's see what we have. This got canceled here, but I do have my negative sign out front. And then I see I have m to the 3rd, and I canceled this here, so m to the 4th. And then n here squared. Looks like my denominator completely canceled out, so I guess I don't really need to write over 1, so I'll just circle my answer. For letter D here, you could write it out a couple times, kind of like what we did here, or you can just distribute your square. I'm just going to distribute my square this time. So 3 squared y squared over r squared, you got 2 of those. So 9y squared over r to the 4th power. All right, there are 3 problems left. They're kind of challenging problems, so maybe you want to try and pause the video, and then once you try them, hit play and we'll check and see if you did them right. Give yourself a little challenge here today. For the first example here, I'm going to start by reducing my 42 and my 6. So I'm going to reduce and make this a 7 and this a 1. And then as I'm looking, I have x's in the numerator and x's in the denominator. And this rule, what we want to do is subtract our powers. Because x to the 10th would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. Y to the 5th would be 5y's. So instead of having to expand this every time, it's much quicker to just, if you knew the rule, subtract your powers. So if I cancel the 3 that are alike, then I have 7 x's left over, so x to the 7th. And then I have 4 y's left over, so y to the 4th. But if you knew the rule, if you just subtract your power, which is what we did on this page over here, subtract, it would save you some time. Now here's the next one, 5r cubed s to the 6. But then this group here I want to square. 4 squared, r squared, s squared, squared. And then we'll start working with the denominator. First I'm going to address this right here. So 5r cubed s to the 6. 4 squared is 16. R squared and s now multiply. So 2 times 2 would be a 4 for my s. In the denominator, 20 r to the 4th, s to the 8th. Now I'm going to just kind of rearrange the top, and I'm going to put some things together here. 5 times my 16 I want in front because I want to do some canceling with that 20. Now if I have r squared and r to the 3rd, the total amount of r's I have in the numerator is 5. S to the 6 here, s to the 4th here, the total amount of s's I have on the top is 10. And now I just kind of simplified this a little bit for us, so now we can really compare. 20 and 5, I can do some canceling here. 5 goes into 24 times. And I also see that 4 and 16 can reduce. So this actually goes away, and I'm left with the number, just my numbers, I'm left with 4 in the top. Now, 5 s's in the top, 5 r's in the top, excuse me, not s, and 4 r's in the bottom. I have 1 more r in the top. And 10 compared to 8, there are 2 more s's in the top because 10 is, if I subtract 8, I have 2 left over, and those 2 left over are in the numerator, which means I have no denominator here because I canceled them out. Subtract your powers. 5 minus 4 is 1. 10 minus 8 is 2. Now the last one here, what we want to do is kind of like what we did here, address our square. I'm going to address a square here, a cube here, and a to the 4th power there. So let's work on that first. So 3 squared is 9. A cubed squared, so if I multiply a power times a power, I get 6. B to the 8th. Now if I cube this, -4 times -4 times -4, I am going to have a negative here. 64. A cubed, B cubed. Now the denominator, 2 to the 4th. 2 to the 4th. 2 times 2 is 4. 16 here. A to the 4th. Distribute your power to every letter and every number. B, my power, 2 times 4 is 8 here. Now this one I don't need to multiply, thankfully, so 3a cubed and b. Now what I'm going to do, kind of like what I did here, is combine my letters on the top, combine my letters on the bottom, and just bump my numbers out front. So I have a -64, I like that negative out front, and then times 9. Now total A's on the top, 6 here, 3 here, add those together, you get 9. B's here, B's here. If I add 8 plus 3, I get 11 total for the top. And then 16 times 3 for the bottom. Notice how I'm kind of aligning things that I know I can do some canceling with. 4 A's here and 3 A's here. 4 plus 3 is 7. And then in the bottom, 8 plus 1 more would be 9. Now I know I can do some canceling here. 3 and 1. 16 goes into 64 times, I believe, 4. Let me get my calculator and double check. -64 divided by 16. Yeah, 4. So 4 times 3, I get 4. And now let's take a look. 4 times 3 is 12, sorry. Now my A's. I have 2 more A's in the top. I have 2 more B's in the top, and then I'd be left with 1. So 4 times 3 is all I needed to do there. Oh, no, 2. 11 minus 9 is 2. And that would be our answer. Oh, negative. I almost didn't catch that. Negative. Make sure you got your answers negative. Great job.